Find the equation of the tangent line for g of x equals cosine 2x divided by sine 2x plus 1 at the point x equals 0. To find the equation of the tangent line, we need the x and y coordinates of the point. Well, right now we only have the x coordinate of the point. So the first thing we need to do is find the corresponding y coordinate by plugging that x coordinate into the function. G of x equals cosine of 2x divided by sine of 2x plus 1. Our y coordinate will be this function evaluated at the x coordinate of 0. So we're going to plug a 0 in for all the x's. We will have cosine of 2 times 0 divided by the sine of 2 times 0 plus 1. 2 times 0 is 0, so we'll have the cosine of 0 over the sine of 0 plus 1. The cosine of 0 is a 1. The sine of 0 is a 0. And so we'll have 1 over 1, or 1. So the x-coordinate of 0 given to us has a corresponding y-coordinate of 1. So we have the point 0, 1. The next thing we need is the slope of the tangent line, and that's the derivative. So now we're going to evaluate the derivative g prime of x. Now our function g of x is a quotient of two functions, and therefore we'll make use of the quotient rule. The derivative of the numerator, derivative of cosine, is negative sine, leave its inside alone, 2x, and then multiply by the derivative of the inside to complete the chain rule, so times 2. All of that times the denominator left alone, and then minus the numerator left alone, times the derivative of the denominator. Derivative of a sine 2x is cosine 2x, leave the inside of it alone, but multiply by the derivative of its inside to complete the chain rule. The derivative of 1 is a 0. All of this is divided then by the denominator squared. Sine of 2x plus 1 quantity squared. We'll want to simplify this a little bit before we evaluate it. So g prime of x equals 2. What I'm going to do here is put the constant first, so I have a negative 2 sine 2x times a sine 2x plus 1. And then I have a negative, I'll put the constant here first as well. I'll move that 2 to the front, and I have cosine times cosine. We can call that cosine squared, 2x. I can distribute the negative 2 sine 2x into all of this, and I'll want to do that in my next step. All this is over the denominator. We won't do anything with that, just leave that alone. Distributing, I have a negative 2 sine squared 2x, a negative 2 sine 2x. I have that negative 2 cosine squared 2x, and all this over the denominator left alone, so sine 2x plus 1 quantity squared. Now for our derivative, I'm going to group together this term and this term because we are going to have an identity, and the identity will happen anytime you have sine squared and cosine squared and they have the same coefficient, whether it be positive or negative. They're both negative here. And so we can group those together. This will just help us simplify the form of the derivative. I'm now going to factor out the negative 2, and I will have a negative 2 times the sine squared of 2x. It'll now be plus cosine squared of 2x by factoring out the negative 2. And I'm only factoring out of those two. I'm not going to factor out of this other term because this other term is not involved in the identity. All of this is going to become a 1. we're doing all of this so that we can simplify the form of the derivative before we actually plug in. So our g prime of x will be a negative 2 minus 2 sine of 2x divided by sine of 2x plus 1 quantity squared. Our slope is found by plugging the x-coordinate in. Our x-coordinate is 0, so plug in a 0 to this derivative, so g prime is 0, which will be minus 2 times the sine of 2 times a 0 all over a sine of 2 times a 0 plus 1 squared. Well, 2 times 0 is a 0. So we will have sine of 0. And it turns out that sine of 0 is 0. So we have minus 2 and minus 2 times 0 over 0 plus 1 squared. So minus 2 minus 0 over 1 squared. Of course, minus 2 minus 0 is just minus 2, and 1 squared is 1. Negative 2 over 1 gives us a negative 2. There's our slope. And we have our point. So we can now make use of the point-slope formula. Y minus the y-coordinate of the point, which is a 1, equals the slope, which we just found to be negative 2, and then x minus the x-coordinate of the point, which is a 0. We can distribute the negative 2 in there, and that will give us negative 2x plus a 0. We don't need to write that. We want to solve for y. That's called the slope-intercept form, and that's the way that we will always find the equation of the tangent line written. And I'm going to find that by adding 1 to both sides. And it looks like I'm getting my equation of my tangent line for the function g of x at the point x equals 0 to be y equals negative 2x plus 1.